This is a video for MEI Core Pure Mathematics, Calculus 5, Volumes of Revolution and Mean of a Function. 5.1 Introduction. You already know that integration is a limiting process where the sum of rectangles underneath the curve is used to approximate the area. We then allow the rectangle widths to get smaller and hence get a more accurate approximation to the area. Let's have a look at this diagram. Let's call these limits here A and B. The area I'm interested in is this green area, so it's limited by A and B under the function fx. And let's further look at this element here, this red bar, which is of width delta x at position x, and so has a height of fx. I'm going to say that the area of this is delta A. The area is approximately then the sum of all those rectangles. So it's the sum of all those delta A's. And that's going to be the sum of all of the heights times the widths. And if I look at the limit as delta x tends to naught, in other words, as that gets thinner and thinner and I get more rectangles for this thing, so that's fx delta x, what happens is this infinite sum becomes the integral, and its fx and the delta x becomes dx. And so my expression for the area is the integral between a and b of fx dx. And there it is, just written out a little bit more neatly so you can follow that through. Now exactly the same idea can be used when we're looking at a volume of revolution. Here I've got the region underneath this curve, which has been rotated about this axis to form this volume of revolution. And I've split it into individual elements. Let's look at the green one. This green element is a cylinder, and the radius for this cylinder is going to be the value of the function, and the height, or width if you prefer, is going to be delta x. So here I've got a few quite wide cylinders, and here I've got quite a lot of narrower cylinders. For this green cylinder, its volume, let's call it delta V, is going to be equal to pi r squared h, which is going to be pi fx squared delta x. And the same thing can be applied when I get more cylinders, and in fact what we do is we allow delta x to tend to 0 and see what happens. We'll investigate this idea in greater detail in the next videos. And the next video in this sequence is calculating the volume of revolution, where you've got rotation about the x-axis.